All right, so.
Seymour, you wish you go first. Who said that?
Doesn't it get easier
to be able to go.
It does. All right, so hopefully at this point you are. Huh? Yes.
I need to.
I grabbed the notes for you.
All right, so in this, guys, hopefully you're not feeling too overwhelmed right now with the 5 sets of circumstances for the synthesis reactions and then 5 sets of circumstances for the decomposition reactions and how they'll process and how they go.
Stop. We need our freshmen in an orderly manner, please. They come to the hand for the career fair. Teachers, if you have all freshmen, please come down with them and walk through with them, please.
You do realize we got 5 minutes, they're going to do sophomore.
I just got held back. I got to go.
I got to go.
Yeah.
They're going to let them walk through. All right, so in this, today we are going to talk of the next type of reaction. Now in this, do not be feeling overwhelmed with these. It does get easier from here. What I've given you is the activity series for metals and non-metals of single replacement reactions. Do you think I'm going to give this to you on a quiz?
Yes. No.
Hopefully.
You told us. Yeah.
Once in your life I will. What you will have is what you see is what you get. On quiz day, next Friday, you will have the periodic table, and on the back, I will have the activity series printed. So you will have both. Now in this, it is crucially important that you understand how this thing works and how it operates. That's what you're going to need to know. So in this activity series is used for our single replacement reactions. Now please, yes, just for single. Please behave today, don't scream out names.
I'll know who you're talking about.
I heard you spilled the beans.
I do, only got a big block though.
Well, I can put it up there. I don't
I
care.
heard you spilled the beans the other day after I left.
I didn't do that.
We heard you split the business.
Can we stop ruining the video?
What is it?
I didn't do nothing to nobody. I just said I was glad to leave.
I thought Kaylee was.
No, Michael.
Alright, so in this single replacement reaction, remember the general overview of this. You got A that's over here, hanging out, chilling, relaxing, shooting some b-ball outside of school. Then you got this lovely couple, BX. They're just like so madly in love with each other. And then out of nowhere, X sees A, and X is like, peace out, B.
I'm very familiar.
Felt that one.
So A and X are now together, and B is.
This is like everyone.
So what happened to me?
Where is Addie Carson when we need her?
I thought that was
She would just make 30%.
She would. So in this, and how I changed key and pitches 6 different times. So in this is the key. In single replacement, we use activity series to determine if reaction takes place and the products now in this we're going to go through a couple of examples. I'm going to show you how you're going to use this activity series. Okay, you're literally looking at what you're needing to find is what's A and what's B. Once you find A and B, then you're good. But you got to find them first. So in this case, if Mr. Hall decided to do a reaction, that was of a zinc 2 metal. So zinc 2 metal. Now in this, the reason I'm giving you the charge here is so that later on, if the products form, you have the charge of that zinc metal so you can get the right chemical formulas for the products. So in this, you got zinc metal, and with this, let's say we're going to react it with copper 2 sulfate. So copper 2 sulfate. Now in this, like I said, you have to have your nomenclature skills to get this. If you do not have the nomenclature skills, this is going to be
I don't have any skills
Is
with
that fun?
rough.
my brain's not really functioning at all.
So then this, you got zinc 2 metal, so it's just zinc by itself, plus copper 2 sulfate. It's copper Cu, it's a 2 plus charge. Sulfate's SO4, 2 negative. It's a 1-to-1 ratio, so it's just Cu, SO4. So now in this, what you have to determine are which of these are trying to replace one another. So, in this, you're looking for what's alike. Metals like to replace metals, and non-metals like to replace non-metals.
The office, please.
Yes.
Dakota Brown, Ethan Blackburn.
On our quiz, can you give us the relationship statuses? Like that? Yeah.
No, you can write it down, man.
Yeah, but
Say, Jack and Jill got divorced.
yeah, but those are a
And
lot to
then Amy
remember.
Welcome to chemistry.
Oh my goodness.
So my childhood was just ruined because I
Eric McClanahan, come to the office, please.
So my childhood was just ruined because Amy couldn't anymore.
So in this, zinc is the one by itself, so it's trying to replace something. In this case, it's going to try and replace another metal. Now this isn't always true. There is an exception to the metal replacing only a metal. Metals will also replace hydrogen. That's why you see hydrogen sitting there with the metals in the activity series. Okay? So now we're looking at zinc trying to replace copper. Now we have to look at our activity series and determine whatever is highest is most active. Most active will replace less active. So in this case, whichever one of these are higher up is the one that's going to sit here. So you got to look on here, find zinc, and find copper. So when you find zinc, you'll find zinc right here in the second box. And then you'll find copper down here in this bottom box.
Zinc is higher.
Zinc is higher, which means zinc will replace copper. So this is the part where zinc comes in here. It's like, hey, yo, sulfate. Lose the zero, get with the hero.
Oh, that's a good one.
Oh, yeah.
Did you just make that up?
Now I've heard it like 1,700 times. I thought y'all were going to say, wow, I got a new line, Mr. Hall. That's old.
Oh.
So then copper comes out here. Copper's by itself. Because now it's all alone. Or sad copper. Plus zinc, which has a 2 plus charge, and sulfate, which has a 2 negative charge, so a 1-to-1 ratio. So then we get zinc sulfate. So now in this,
Do you have to balance? Oh, well, the.
yes, you always have to balance.
But like, okay, so this one, like, what would you put first? Your zinc
You wouldn't because.
If we know for a fact that it
Like
runs,
what?
do we still have to put it?
No, like guys, I don't even care. Like even when you get the quiz, you don't have to put this down. This is a system that I use, that I taught to you, so that you can use it to help you find the balance. If you can just balance it by looking at it, balance it by looking at it. I do not care. Now question, why do I have sulfate together here?
Because it's one thing.
It's one thing, it's a polyatomic that shows up on the left and on the right. It shows up together so I can keep it together. Makes my balancing a lot easier. Everything's 1-to-1, so this is already balanced, so that reaction is done. So here's the thing. Don't fall into a trap that these reactions will always take place. So if we change this around to be the reverse reaction, will the reaction take place? So what I'm saying is if we have copper plus zinc sulfate,
You literally just.
It'd be the same exact thing.
no it won't.
Why?
Look at the activity series. What's trying to replace what? Copper's trying to replace zinc. Which one's higher? Zinc's higher up on your activity series. Since it's up here and copper's down here, copper will not replace it. In that case, this is no reaction.
Are we expected to memorize this by at one point?
No.
Good.
Will there be a lot like that where it's no reaction?
Could be, could not be. That's just the question.
There's nowhere in the mind to suffer the stings and arrows of outrageous.
She only smudge.
Shut up with that.
Every day. I relate to it more and more.
Yeah.
And by posting in them, die, sleep,
But I still don't understand how it's no reaction. I didn't learn that.
Zinc's higher up. Zinc's more active. Copper won't replace it.
I'll be okay.
Look at your activity series. Good?
So the other one's higher if you want.
Nope. The higher one will replace. If you're trying to replace it with something that's below it, it will not replace it.
I feel like a YouTuber. Look at that. I'm a YouTuber. That's really bad. I've never. I just got, and she's only small. That was my fault. I'm a YouTuber. I just stopped.
All right.
Get on your finger though.
Let's work another one.
Yeah, I'm a YouTuber now. This is what YouTubers do. They get paid millions of dollars.
Memorize all else.
There's, I have hands
Okay.
There's towels.
Let's say we got cadmium.
To the office.
So we got cadmium, and with cadmium, let's say we are reacting it with sulfuric acid. And you all remember sulfuric acid? Just because it's burned in your brains.
Oh.
Pretty much.
I'm getting bullied. Somebody's up
So in this, find what's trying to replace what. In this case, you have a metal, cadmium.
I've never heard of that before.
It kind of sounds like catnip.
Definitely.
So is it going to replace the hydrogen or the sulfate?
Hydrogen.
Hydrogen. Why do you know it's hydrogen?
Hydrogen's lower than.
Because that's what's on the activity series. The polyatomics are never going to be replaced.
This is easy.
So in this, hydrogen's going to be replaced. So you go over to the right, hydrogen's kicked out all by itself. Leaves you with H2. It's H2 because it's a diatomic, not because there was two hydrogens right there. Hydrogen by itself is a diatomic. And then along with that, the cadmium is going to replace it, and in this case, this is cadmium 2. So it's a 2+ charge, and sulfate charge is 2 negative, so a 1-to-1 ratio, which gives us cadmium sulfate.
And they are already equal, right?
Already balanced. Okay?
But if acidity was where that hydrogen is, there's no reaction.
That's right. Alright, you guys give this a shot.
That means buttery, yeah. Like smooth. That'd be really pretty. I'll mix them all.
You guys give that one a shot. You say this is mercury 2.
I mix the 3 on my hand. Faith, go back up there. Oh yeah, she has to stay there for that. Okay,
Would y'all trust the trade school people to cut your Like, I'm at that point in my life.
Eric does pretty good, but he doesn't?
That one's not.
He showed me a hairstyle he did my sister. I was like,
Alright. Alright, here we go. What'd y'all get? What will replace what?
I just feel like I got
my bangs. I got my
I
bangs.
thought it was mercury was lower than hydrogen.
So no reaction.
Well, I didn't know it was my bad. I didn't know what it was called.
I would take off for that.
Oh, I'm sorry. I didn't know what it was called. So I couldn't remember.
No reaction.
Do you know Mike was so smart? He got a scholarship in the
The
extra.
only woman I trust with my
She'll make it fun of me because
she
I
was up
that's why I applied for a scholarship. I did.
and she
I was one of the head of my class in band, and I received a scholarship.
Alright. Here you go.
do they have
It doesn't matter to me. I was just cracking a joke.
Y'all love each other today. Sweet Jesus.
No, I get it.
Alright, so let's flip it. Chill. Alright. Here are your reactants. Give me a proper chemical equation for this. In these, you need to be able to recognize there is something by itself and then there is a compound, which means you've got an A and a BX. You need to realize it's a single replacement and make it happen.
Can I ask a dumb question?
Absolutely.
With the single replacement, will we just need the activity sheet or will we need our periodic table?
You'll need periodic table too.
Yeah. You're tricking us.
no reaction?
You ready for it?
That's
Will chlorine replace sodium? No, that's correct. Why?
Because it's way lower.
No, because fluorine is a non-metal and sodium is a metal. A non-metal is not looking to replace a metal.
Right.
A non-metal is looking to replace a non-metal, like iodine. That is on your sheet at the very bottom where it says non-metals. So now you're looking for chlorine. Chlorine's trying to pop in here and take the iodine out. Iodine is lower. So I by itself. Okay, so I plus
I really don't want to get out psych though.
that. Because the sodium has to come first because it's the cation. That's also still wrong.
Is it?
I too, because iodine is a diatomic. If you are not taking notes, I highly recommend getting some paper, pencil out, and taking notes.
Everything you've ever wrote on the book.
I didn't know single replacement was going to be this
Mikey, are you
hard.
being mean to my friend?
Now in this, are we done?
No.
Why?
They're not balanced.
Not balanced.
Welcome to the chiropractor now. Take your time.
You need to put a,
2 after everything but CL2.
you need to put a 2 in front of NAI and then
Okay, so if I put a 2 here, it changes sodium and iodine, gives me 2 of those.
Don't put a 2 in front of the second
you need,
over here.
yeah, you have to.
Put in
Because,
front of the eye.
So over here, there's already 2 of them.
no, there's, not with the I, yeah, there's already 2 there, but you need the NaCl, don't you?
Yeah, you need
You have to put 2 in front of it.
NaCl.
Now.
And you were talking about putting it in front of the I,
I
weren't you?
said don't put it in front of the eye, and you said to put it in front of the eye.
You guys
No, I
were
was-
both right, but then both of y'all were misunderstanding what each other was saying.
Yeah, I just got that.
Yeah.
Now everything is balanced, everything is good, peachy, happy, and go lucky.
I'm not gonna lie, I felt so sorry for you.
Okay?
It was horrible.
Felt sorry for y'all during all this.
Why?
No.
She stepped in there saying, and then it was like 4 minutes. Like, oh, okay.
What?
Why'd you walk out of the room?
I don't know. Oh, to do the Sublock Tango.
You're not understanding. Don't worry about it.
I hope I
Alright, so in this, you guys have seen a replacement of a metal in a compound by another metal. Now within this, I'm so proud of y'all. We are rolling right along. We are ahead of second period. This is great.
Does this mean I can take a nap finally?
No. So within this, we're going to talk about the replacement of hydrogen.
I'm legit just rotting back here. And she's like freaking out.
Replacement of hydrogen in water by metal.
Did y'all get? Did she start doing that? Now I remember why I walked out.
I just got used
So there are certain cases and standards of things that you'll see within the single replacements. So within this, if you take a group 1 active metal, so group 1 active metal, and toss it within water. So we'll find out, will come from this, is active metal
That's what it produces?
hydroxide and hydrogen
Is
gas.
that what it produces?
You mean group 1 for
Which side is the products?
That's what it produces?
That's the product.
You mean group 1 for this or that?
That. Group 1 off periodic. I think they're both the same. No, it's not both the same.
Is it possible for you to give us like the balanced equation and make us like a graphic one? Do we have to do that? Like, you know how like we write how it's balanced, like with the,
You balance them, yeah.
yeah, we. I'm getting make fun of. Is there any way like you'll just give us that and we have to like reverse it? You know what I'm saying?
No, because
Dakota
we're going to give you a
Atkins, city
balanced
office,
equation.
Dakota
I
Atkins.
have to give you reactants and products and balance and all that.
It's good.
If I give you that, you're looking at stoichiometry. Which is coming.
How can you just skip over all this and go to stoichiometry?
Stoichiometry.
You can.
Well,
Not in it entirely.
Welcome back, and today we will be doing stoichiometry.
I got you. I got what you're saying.
that's
At,
peace.
at that location,
They do.
they
Oh,
don't
sorry.
give you guys,
They're fuddy duddies.
you're not given the reaction and say get the products or nothing. They're just saying these are the types of reactions and have you identify this is a synthesis reaction, this is a single replacement, double replacement, and then they just give it to you.
I'm about to go in there. You're still a straight.
That's,
But here,
that really is so.
we don't take the concepts of chemistry and babyfy them and water them down.
They just,
I would like that.
No.
they just.
Because when you go to college, you will be much more happier that you had this class.
I probably won't even have to take chemistry in college.
What are you gonna do?
Speech pathology,
You gotta take some sort of science.
forensics.
Mr. Hall.
I'll take environmental.
What? Alright, so in this, so if we took something, for example, let's just say, like, whenever we do titrations in here, we're gonna deal with this base. So, if we had sodium, where is sodium? On periodic table, where's sodium?
Ain't it NA or?
Na, it's the first column. So it's group 1 plus water. Here's the thing, is it will displace hydrogen off. So hydrogen gas will be released. But it also gives us active metal. I don't know why I said active hydroxide. It also gives us the active metal hydroxide. What's the active metal? Sodium. So Na and hydroxide. What's the charge on the sodium? Plus 1. What's the charge on the hydroxide? -1, so it's just a 1-to-1 ratio, so NaOH. So this is what we are looking at. This chemical formula right here. This is a single replacement. Now in this, check and see if you're balanced.
No.
Nope. Alright, so in this, everything's balanced with the hydrogens. Remember the trick with the hydrogens.
You save them for.
But this one's going to get interesting because the hydrogens are broke free over here, completely separate from each other. So within this, we're going to have to try a little bit of fun stuff with it.
Let's just erase that H and put 3. Not going to happen.
Alright, so in this, we have 2 over here.
Switch them.
I'm going to say let's stick a 2 here to get an even number.
Are you sure?
Take it. Yeah.
Is that your final answer?
Yes.
What?
So I stick a 2 there in front of the sodium hydroxide. That changes my sodium, changes my hydrogens, and changes my oxygens. So now in this, I now have 2 sodiums. I now have 4 hydrogens, 2 coming from here, 2 from here. And I have 2 oxygens.
Oh, Miss Raw.
So now we're going to jump over to the left side,
And I'm going to the sodium.
and I would put a 2 with the H's. Or the NA. No.
Put 2 in front of both.
Put a 1 in front of the NA.
Go to the front. Yeah.
You know that cat
Trust
meme
me.
that's like,
Tell me put a 2. Put a 2.
I'm sorry.
Put a 2.
Okay, 80, we'll go with it.
Put a 2.
2 in front of the sodium gives me 2 sodiums. Now the sodiums are balanced. The hydrogens are not balanced, so I got to balance them. This is why I did the even number. I got the even number over here because I have 2 over here, so I can evenly divide it out. So if I stick a 2 in front of here, that'll give me the 4 hydrogens I need, but it also gives me 2 oxygens, and we are now balanced.
That was easy. Easy peasy lemon squeezy.
I'm a con person.
Except for I don't know where you got that one.
That's really sweet.
Okay. So in this, you have less active metals.
I think about that.
Will react with water. Whenever they do this, this will yield to a metal oxide plus hydrogen gas. The key to this water, this just isn't normal water. It's steam. It has to be steam.
Is that a chemical reaction? When steam gets wrinkles out?
No, that's a physical change. So in this, we got the less active metals, so we can go with, let's choose one of the D block dudes. Let's just go with iron. So if we did iron, and just for common purpose, we'll do an iron 3 on this. I don't know.
Will we always know the iron, or do we have to find it?
I will tell you. Unless I give you the products and make you work backwards. So iron 3 plus H2O. And here's how we can denote that it is steam, is putting a little G here because that stands for gas. Not the gasoline you put in your car.
That will probably kill you.
For the best of Mr. Holmes.
That was some nasty stuff. So in this you get the metal oxide, so we'll have iron, iron 3 plus, and oxygens, 2 negatives, so we'll get Fe2O3 plus hydrogen gas. No longer need to know it's iron 3 now. Now we are looking to balance. I'm going to stick with my system.
So we put the G with the O.
Oh. No, it's next to the whole molecule. Alright, so within this, I got on the reactant side 1 iron 2 hydrogens, 1 oxygen. Product side, 2 irons, 2 hydrogens, and 3 oxygens. So now we are looking to balance.
Okay.
You need to put 3 in from
On
each
your left side,
two.
you need to put a 2 in front of your FE.
Okay, so reactant side, put a 2, gives me 2 irons.
Now you just need to work on your others.
But if he works on his others, then the H's will change.
You need to put a 3 in front of Fe2O3, don't you?
The 3 in front of the H and the 2, and the 3 in front
Wait a
of the
minute.
H on both
I
sides.
think I was wrong.
I think you should put a.
No,
No, it's
you're not wrong. You're fine.
Okay, that's
Here's the thing. Look at the situation. We're going to flip this, and we're not going to save oxygen for very last. We're going to save hydrogen for very last. And this is why. What's totally by itself? I have a hydrogen over here that's totally by itself. So I'm going to balance the oxygens, and then I'm going to jump back and balance the hydrogen.
So it should be a 3
I
at
look
each
at it
iron.
like, what's the highest one I have to match?
So I got a 3 here now that changes the hydrogens and the oxygens. So I now have 6 hydrogens and 3 oxygens on the reactant
A
side.
3 in front of the other before.
But now I've got to balance over here for the hydrogens. I got 2 right now.